Welcome, I'm Jesse, this is Jeff. We are from Vegas Forge, and while we have you guys here, we want to show you how we do what we do. We make Damascus steel, and we want to show you why our stuff doesn't have any delaminations, voids, or any flaws. So we're going to take you through the process and let you know exactly how we do it.
So we have about 8 different stack patterns that we use to create our different patterns. This is an example of what we use for things like random, raindrop, ladder, patterns like that. We have all our stock materials cut up, ready to stack. They do range anywhere from about 180 layers with random to about 1700 individual pieces for our spirograph. So kind of how it works, we'll cut each individual piece to size and the amount of pieces or layers that we're going to need for that stack. Once that's done and washed, which we'll show you here in a second, we're going to box the material, and Jesse will explain why we box instead of.
So if you're doing 200 layers, then you'll have your piece of AEBL, which is a little bit thicker, 10 times thicker than this 302. So we'll do 1 layer of that, 1 layer 302, and we'll do that, stack it all the way up, 200 layers thick. Then once those are all stacked up, they go inside of a can like this that we custom build for each box. And then this gets shut. You can imagine this closing, it's too stiff for me to close. And then everything is welded up like that right there. So all this material is closed up and sealed inside this can. It's airtight in there. And then we have this little hose right here that enters the can, and we're spraying some WD-40 in there right before we forge it, and that sucks all the air out of the material, and that allows it to not scale. And by scaling, what we mean is the oxidation that happens when you forge. So you can see this piece was just hammered, and the part that's exposed to the forge, to the air, it'll get this little scale like this. And if that part right there gets in between these layers before they're fused together, then you have a bad product, and you'll have a delamination, or you'll have a void in the metal. And so it's really important in the first part of this fusion that these layers are perfectly clean, they're canned inside of here, real tight, and that you do everything you can to get all the air out of, all the oxygen out of this so that you don't get any oxidation. And if you do it right, you get a solid piece of steel that's as solid as any chunk of steel that you'd be familiar with. This right here is actually semi, you might be able to see it. So we got a core, so it's about 30 layers of this AEBL right in the core, and then interlaying layers like this on either side, and that's been fused together. And this is what we're going to draw out and show you guys today, how to make San-mai. So the first step would be what we just showed you, and now we're going to show you the forging.
All right, go. So another way that we ensure that not only that we won't find any cracks or voids after forging it, but the customer, when they receive the project and are working it, they don't end up with any cracks or voids in the product. We'll actually hand wash every single piece. And so put it through a little bit of a process, make sure we wash any dirt, grease, anything like that off of it. Also wear gloves, just making sure no oils from the hands or anything like that ends up on the metal as well. So put it through there, wash it, and then we'll dry, making sure that each individual piece is nice and clean.
So here we have that boxed up can of material. So we have the 200 layers of steel here, and this is San-mai. So we have core material, so that's 30 layers of the 1075 steel. And the way we do our carbon Damascus is we have it all canned up. We have a little hose that goes inside the box, and then we shoot some WD-40 in there. What that's going to do, shoot it in there. That's going to get inside of there. I'm going to throw it in the forge. That'll catch on fire. That'll suck all the oxygen out of the box, and then give your metal a lot better of a fusion than if you were to just weld at the sides of the steel and not have it in a can. This is by far the best way to do carbon Damascus, at least in our opinion. So here we go, let's stick it in. Now that's going to heat up for probably about an hour and a half. We like to let it soak. It'll get to 2200 degrees. And then when it gets to that, we'll take it out and we'll throw it on the 5B here and we'll hammer it, fuse it all together.
So after we're done forging the box, in order to be able to machine it or cut it, we anneal it. What annealing does is it puts the metal back in a softened state where you can machine it without tearing up your tooling. It takes about 10 to 12 hours, so we do it overnight, so we're ready in the morning when we get back into the shop. So what we'll do is we'll cut it off. We're going to figure out what the density of this box is so that when someone calls in, makes a custom order, we have an equation which we can figure out exactly how much of this that we need to cut off in order to complete that order. And so yeah, we'll measure it out, cut it on the saw, weld a handle on it, start the forge process again.
Now we got our forge at 2200 degrees, so the box is at that same temperature. I'm going to put on the hammer and I'm going to hammer the top of it a few times, probably 4 or 5 different hits. Then I'll flip it on its side, tap it in, and hit the top again, and we'll just start drawing that box together, tightening it up. So that's all fused up. Now you can get it any way you want, and it won't break apart. So now the next step is cut it up, draw it out into whatever finished product we're going to do, whether it's a flat bar, round bar. That's the next step. This now is one solid chunk of steel, 200 layers. Now we're on the 3B hammer, so we use the 3B to draw out all of our finished products. So what we're going to do with this product that we just forged out in this video is do a 2-inch wide billet, and then we'll make it 16 inches long and 1/4 inch thick. So the first step of doing that, drawing that out, is going to be to hammer that billet, that chunk of steel, to 2 inches wide, 1 inch thick. And once it's that point, we use the rolling mill over here, and we'll roll that chunk of steel little by little into a finished 16-inch long billet for a knife blank. So we'll start with that. So this is a chunk off that box we just forged, and we've done the equation to get it right side. we got the thickness that we want with the width. And we got thin enough on the sides that we can start using the rolling mill to draw that. We're going to draw it out. It's probably going to be 25 inches long. That'll give us some extra material for inventory. So now we're going to use the rolling mill. And we're going to start drawing that billet out. We drop about 25 to 50 thousandths at a time. So we'll roll it, heat it back up, and roll it again. We do that about 15, 20 times depending on the thickness of the end result that we're looking for. So we're going to get that going. You can see that San Mai core in there. That's that solid yellow without the lines. Do that, drop it down on one more thing, stick it back in. We'll just keep doing that. You do it about 3 times before you have to reheat it with this particular material. The other patterns like spirograph or herringbone, you can only roll 1 time before you have to reheat. But yeah, you can see that.
Hold on. Yep.
Now we'll reheat it. We'll keep going until it's ½ inch thick. Alright, so now we have our billet rolled out to the thickness that we want, and the next step for the pattern that we're doing, we're going to do ladder pattern, is to press into that billet, and that's going to manipulate those 200 layers of steel inside. We can manipulate them and bring them to the surface. That's how we get our ladder pattern. So we'll go ahead and do that and show you how we make that happen. Straight in there and then crank it down. You see it on the side, that's brought in, indented that billet that much. Next step is we'll take a surface grinder and clean off that until it's just clean flat steel. And under that material there will be the finished pattern, ladder pattern.
That's it.